Hello everyone, today we're going to take a look at solving a force problem, okay? And so let's take a look at the question. I'm going to walk you through the steps. First, if a 60 kilogram volleyball player runs and serves a 0.3 kilogram volleyball with a horizontal force of 45 newtons, what would the acceleration of the volleyball be? Okay, draw a free body diagram for both the volleyball and the player, okay? Free body diagrams are your friends, okay? That is how you solve any force problem. First off, you got to figure out what is acting on each object, okay? And so if you watch volleyball runs, we're going to assume they're jumping here. So then let's do free body diagram. Let's do the volleyball first. So the volleyball here. Whoops. Volleyball. Okay, so we're going to start off with a dot. And it's, what do we say, 0.3 kilograms. And so first we know gravity's acting on it. Gravity is always acting on any object, okay? And we know that the force of gravity is equal to the mass times acceleration due to gravity, which is equal to 9.81 meters per second, or 10, because 10's easier and it's a 2% difference. So we're gonna use 10 here, okay? So that is equal to 3 newtons here, and Earth is exerting that gravity. Okay, what else is acting on it? Okay, the volleyball, we're going to assume they are serving it to the right. Serving to the right. Okay, so I've got my applied force here. It's going to be quite a bit bigger because it's 45 newtons. I'm going to call that an applied force, 45 newtons, because of the player. Okay. We're assuming they're jumping high enough and they're going to hit it exactly horizontal to make this a lot easier. Okay, as the ball is being hit, nothing is really holding it up. Nothing's really going against backwards. So our free body diagram at this point is done. Okay, so for the player, okay, they're 60 kilograms. We know gravity's acting on it because the force of gravity is equal to 60 kilograms times 10 meters per second. And their force of gravity is going to be 600 newtons. So we've got, boom, okay, this one will be to scale on its own. So Fg, because of Earth, is equal to 600 newtons. Okay. They're jumping up in the air, so there's no normal force. They're not staying on the ground. Nothing is pushing them up. So yes, they will be accelerating downwards. Okay. The volleyball is going to exert a force on the player, okay? And as we know, every force has an equal and opposite reaction. All forces come in pairs, okay? So that volleyball is going to apply a force in the opposite direction, okay? So that's going to be force applied from the volleyball. And because there's no way to exert a greater force than is exerted back on you, this applied force is also 45 newtons, okay? Perfect. So now we're going to look at the acceleration of the volleyball. Now, we are only going to look at the acceleration in the horizontal manner right now. We're not going to look at adding vectors, okay? And so we know that unbalanced forces cause acceleration. They're related because the unbalanced force is equal to mass times acceleration, or FUMA, however you'd like to show it, okay? And for the horizontal direction only, horizontal direction, okay, we can see that up here our applied force is unopposed by anything else. So our entire applied force is the unbalanced force. So our unbalanced force is equal to 45 newtons. Okay. If we want to find our acceleration, we know that our 45 newtons is equal to 0.3 kilograms, the mass of the volleyball, times its acceleration. And so acceleration is equal to 45 newtons divided by 0.3 kilograms. And that's going to equal a very large number. Okay, what is it? Let me get a calculator. About 135 or so, I'm thinking. Where is my calculator? Found it. Okay. And so we do 45 divided by 0.3, and we get 150 meters per second per second. Okay, not really realistic example per se, but do know the main thing here is draw the free body diagram, figure out if you've got an unbalanced force, and both forces, okay, these two are our force pairs, right? The player's exerting that force on the ball back on the player, they're equal in magnitude, and then opposite in direction, okay? As always, good luck, have fun, take it easy.